Welcome to Climate Now, a podcast that is focused on accelerating solutions to the climate emergency. We explore and explain the key ideas, technologies, companies, and policies that can help solve the climate and energy challenges that we face, featuring interviews with scientists, entrepreneurs, leaders of large companies, investors, and policymakers. I'm your host, James Lawler, and joining me as co-host today is our managing producer, the one and only Emma Crow-Willard. Emma, welcome.
Thank you. Good to be here again today for this conversation. Today, we're going to talk about our electric grid infrastructure. So, according to the U.S. Energy Information Administration, or the EIA, renewable energy made up about 22% of U.S. electricity sector generation in 2022. And so that includes biomass, wind, solar, geothermal, and hydropower. Nuclear made up 18%, and fossil fuels made up about 60% of electricity sector generation in 2022. So that's still the majority. But, as electricity from renewables is getting cheaper, they are taking up more space on the grid. And since fossil fuel emissions are driving climate change and these impacts are becoming more severe, we want to deploy more clean energy systems.
So, the United States has almost 2 million megawatts of renewable generation projects and storage projects that are in the so-called interconnection queue that are waiting for connection to the electrical grid. Now, one of the blockers to that is transmission infrastructure to actually transmit the power that could be generated over long distances. We wanted to understand this piece of the puzzle. We discussed in our episode on September 26 two views of the future of the US electricity grid. One view being distributed generation, where you're generating from residential solar and sites out at the periphery, versus a more centralized generation infrastructure. But we didn't get into really how we would go about building out the additional transmission that's needed. So, to talk about that and understand the opportunities and the challenges that exist in transmission development, we are joined today by Patrick Whitty. Patrick serves as the Senior Vice President for Public Affairs for Invenergy's transmission business. Invenergy is a developer, owner, and operator of energy infrastructure with projects all over the world. Patrick and his team at Invenergy are responsible for communicating with and engaging with stakeholders on Invenergy's portfolio of transmission projects. Patrick, welcome to Climate Now. It's great to have you on today.
Thanks, James. Really excited to be here.
Let's start with, what is Invenergy? What does the company do?
We're an American-led company, and since Invenergy's founding in 2001 in Illinois, we've successfully developed over 200 large-scale wind and solar and battery storage natural gas projects, over 4,000 miles of transmission and collection line infrastructure to deliver that power to market. And, really the move to clean energy is here, and Invenergy is leading the way in that move to clean energy.
Now, what's the business model for Invenergy?
So we're a developer, owner, and operator of clean energy assets.
Okay.
And so our development side of our business, we're looking at typically greenfield development opportunities. So looking to find locations to site and develop typically wind farms and solar farms, and in-house capabilities, really for every aspect of power project development from the very first stage all the way through operations. We've successfully developed over 30 gigawatts of projects, and today we operate over 20 gigawatts of those projects. So sometimes where we're working to develop projects, and we'll be the long-term owner and operator of those projects, and that owner's mindset is really built into our culture. There are also situations, kind of depending on the regulatory structure of any given state, where we may be doing the early stage development work on a project, and then that project ownership will eventually transition to a utility that will eventually be the owner of those wind and solar farms. So it's a combination of serving utility customers and then also industrial and commercial customers that are moving towards wind and solar.
So help us paint a picture for listeners of the landscape of energy production and distribution in terms of the companies and the players that are involved. Because it's complicated if you're not on the inside. We all have an understanding of utilities, right? We pay our utility bill every month. And then there are these developers, right? Like Invenergy. Could you talk about the relationship between the utilities and the developers? And what are some of the nuances there and distinctions? Are there other kinds of players that comprise kind of the larger ecosystem of partners that deliver our electrons?
So On any given project that Invenergy works on, in almost all cases, we're going to be advancing that project in a project finance model where we will do the early stage development work, engineering work, interconnection work, environmental compliance and permitting work on that project. But at some point, we advance that project to a stage where it is investable. And we would look to bring banks and capital providers that would be investors alongside us in that project, provide the construction financing for the project to build it. And then really depending on what state it's located in, we may have different long-term possibilities for that, whether Invenergy will continue to be the owner and the operator of that, or if it's a project that would be eventually owned by a utility. And in that case, we may still continue to operate it on behalf of that utility. But there are, capital providers, there's original equipment manufacturers who are actually manufacturing the wind technology or the solar technology. Invenergy has recently invested in a solar panel manufacturing operation in Ohio. So we're getting into that part of the supply chain. But there are many different players that come together to make a project like this successful and then to make sure those electrons can be delivered to end users. One other area of the business, which is really the area that I focus most, is the transmission development world. And so there is an increasing need in the United States to both bring renewable energy from where it's harvested in the wind and the sun to the end users, and also to help connect the large regional grids that serve different parts of the country. And so right now we're advancing about 1/3 of the total high voltage direct current transmission capacity that's in development in the United States. So those projects are critical for opening up new access to renewable energy, some of the best sources in the country, and then delivering that power to customers.
Could you actually define transmission for us? Like when we say transmission, what exactly are we talking about? And how does that compare to, say, distribution or sort of the grid as a whole?
So transmission is the ability to move power from one place to another on the bulk power system. So we're talking about higher voltage movement of electricity. This is different from the power lines you would see in your neighborhood that carry power from your local utility service network into your home. What we're really talking about here is moving power between regional grids and utility service territories at a much larger scale and over longer distances.
Hmm. Awesome. So, could you talk about the current state of transmission in the United States and in the grid? Do we have enough transmission? Do we not have enough?
So it took 150 years to build the electric grid that we have today, and 70% of the transmission lines and the power transformers on today's grid are over 25 years old. In the next 30 years, we basically need to triple the capacity of the US electric grid to meet the goals of moving to a clean energy economy. Today, when you look at the generation side of that equation, there are enough wind, solar, and clean energy projects in the pipeline to power nearly 85% of the economy. But 80% of these projects will not move forward without expanding the transmission network.
Where do you get those numbers that you're quoting? Like, what picture of the future would those numbers kind of lead us to?
So that's really based on looking at the energy goals that have been outlined by the Biden administration, whether it's zero carbon electric grid by 2035
Hmm.
or looking at the Paris climate goals of 2050. There's a lot of work that goes in with whether it's National Renewable Energy Laboratory or Lawrence Berkeley National Lab or researchers at Princeton. There's a lot of different organizations that are dedicated to doing the kind of analysis around what solutions are needed. And there are a lot of scenarios that are out there, but in all those scenarios, you've got significant expansion of each of the components that can be adjusted
Hmm.
to make a carbon-free grid work. As we see more extreme weather events that affect the grid, and when these extreme weather events happen, it's not just wind and solar that are affected, but it is every form of energy generation. You have coal plants and gas plants that have struggled during these same events. As we face more extreme weather events, one advantage that transmission offers is the ability to move power from where it's available during situations where maybe one part of the grid is facing outages across all types of generation.
Hmm.
Transmission can move power from where it's available in another part of the country to that region that's in need. And so the ability to build a grid that is bigger than the weather is increasingly critical as we move into the next generation of energy and as we face growing climate challenges in a new reality.
I like that phrase, building a grid that's bigger than the weather. That's a very powerful phrase. How does Invenergy think about the relationship between additional transmission and additional storage? If you have storage that's more widely distributed, is it possible to say, get electrons from point A to point B and store more of them at point B, maybe thereby reducing the need for additional higher voltage, higher power transmission lines going from A to B? Or is that not sort of a real thing?
We look at a lot of solutions in combination with each other. So when we're thinking about and when we're responding to customer interest, there are many situations, especially with our wind and solar generation development, where we are looking at adding storage to that asset
Hmm.
to capture additional power and surplus power when the wind is really blowing or when the sun is really shining, and storing that for later use. I mean, you can literally deliver solar after sundown thanks to batteries.
Hmm.
There are situations where batteries can help avoid additional investment if they're put in the right locations on a grid, but that's typically going to be over some period of time where you're deferring that investment. But the level that the grid needs to grow to meet the energy transition that's underway is going to require substantial additional investment in transmission as well as storage and obviously in renewables.
So let's focus on transmission then and sort of how we can actually get there. You've mentioned how much more we need and on what time scale we need that. What are the blockers right now to actually achieving that, and how do we get through those?
So Invenergy's business is really specific to what's called merchant transmission, where we are developing transmission as an independent developer, going out and finding customers that will enter into agreements on a commercial basis. The merchant business, I would distinguish from the traditional rate based transmission planning. The reason the merchant business is so important in the industry today is because the traditional planning processes have not been successful at advancing the kind of interregional transmission and the long distance transmission needed, both to connect different regions of the grid together and then to access new renewable energy resources. So the projects we're working on, we are advancing through that merchant business model. And when you're looking at a long distance transmission line, these on average can take 10 plus years to develop. So a project like that is a hen house full of chicken and egg challenges.
Hmm.
You are trying to get customers, regulators, landowners, suppliers, workforce, communities, project developers all united around a project and dedicating resources to moving that forward over a long period of time. And that can be a big challenge. And to underscore that, uncertainty is the biggest challenge in transmission development. And that's where we're having this conversation around the importance of permitting reform to provide greater certainty in a process like that.
Okay, so that's the merchant model. Explain the alternative. What is the way that the traditional model doesn't really work? Can you just explain what that is?
Sure. So the regional transmission operators or the independent system operators, there are seven in the U.S. and the way they go about looking at their systems is looking at where are their needs on the system, and they will go through their own multi-year processes. But the RTOs and the ISOs are not accustomed to having conversations with each other about how to bridge needs across systems.
For clarity, ISOs are independent system operators, and RTOs, which are regional transmission organizations, are independent entities that manage the transmission grid and ensure reliable energy delivery. RTOs focus on coordinating power transmission, while ISOs also manage wholesale electricity markets.
There is a regulatory framework. It's called FERC Order 1000, the Federal Energy Regulatory Commission issued an order that laid the groundwork for those conversations to happen and for interregional transmission planning to occur. And no significant lines have been moved forward under that model. And so it's right now either up to merchant developers to move those projects forward, or we need to look to policy solutions to incentivize and to create conditions where interregional lines can move forward.
Patrick, I loved your metaphor of the henhouse full of chicken and egg problems. I want to dive a little deeper to try to paint a picture of the complexity of one of those transmission projects. For an average transmission project, how many different counterparties and stakeholders do you ultimately have to create deals with? How many off takers of the power are you negotiating with?
Sure, you could have as many as a half dozen or more
Okay.
in terms of just the commercial conversations you're having. It would be with a combination of utilities or commercial and industrial companies that have major energy supply needs. So it could be a combination.
Okay. There's this commercial piece. There's clearly the land acquisition piece, right? Where you have to get permission to build the infrastructure. And then there's the permitting piece. What's the hardest part?
It's the totality of moving each of those pieces forward. The United States is not the only country going through a rapid energy transformation. It's happening all around the world. And so these projects are not being moved forward in a vacuum here in the US by our company or others. There are companies all across the world trying to advance projects like this. And so you have intense supply chain competition. And it's amazing how geopolitics can cascade around the world as we're talking about our portfolio of projects with major equipment providers and component providers. You've got Europe moving as fast as they can toward energy independence, given what's gone on with the Russian invasion of Ukraine and the ongoing war there. And just as an example, a German Dutch grid operator, Tenant, placed the largest order the world had ever seen for HVDC converter stations and equipment. And that has cascading effects around the supply chain for everybody else who's waiting in line for the same type of equipment. And so you may have schedule dynamics driven by global events in a really competitive environment like that.
In a very direct way. Wow. If you could wave a magic wand at all of the conundrums that face Invenergy's projects in transmission and fix like two or three things instantaneously, what would those be?
Yeah, it's a great question. You know, in the bipartisan permitting reform discussions that have been going on in Congress right now, the area that we are really focused on is seeing some kind of what's called interregional minimum transfer capacity requirement. What that is going back to the challenges that regional grids have had in moving forward interregional transmission and connecting regions so that we can move large amounts of power from one part of the country to the other. What an interregional minimum transfer capacity standard would do is set some sort of threshold that grids would need to be able to meet around the total amount of power they can move from one grid to the neighboring grid. So there's a framework that's called the Big Wires Bill that would require grids to be able to move 30% of power from one grid to an adjacent grid. And that is really central to this idea of building a grid bigger than the weather, is moving large amounts of power from where it's available to where it's needed.
If that's a minimum amount of power that has to be required to be moved, who has to be in charge of making sure that happens?
The Federal Energy Regulatory Commission would be the body tasked with implementing that law.
And this would be at the ISO level?
Yeah, ISOs and RTOs.
Independent system operators and regional transmission organizations would be required to meet some minimum threshold of the amount of power they would be able to move or regularly move.
Be able to move. So, and really the way this framework is set up is you actually look at what would be considered extreme conditions on the grid, which are really only about 5% of hours during the year. And you look at what is the demand on the system, and then how much as a percentage of that demand can the grid move to a neighbor.
Okay. So let's say you had this minimum threshold, codified in law. Why would that be helpful to you?
It's helpful for a variety of reasons. Most importantly, for keeping the lights on, and also critically importantly for energy affordability and making sure that when you have extreme weather conditions or other extreme grid events, you don't have consumers paying for a extremely scarce resource during those times. And so the ability to pull power from an adjacent region where it's available
Hmm.
can really help minimize both outages and costs.
Got it.
And just as an example, during Winter Storm Uri, where you had Texas experiencing severe grid outages, there was an analysis done that 1,000 megawatts of additional transmission between Texas and its adjacent regions would have equated to $1 billion in cost savings, in addition to keeping the heat on for thousands of Texas.
Wow. So let's say that this law existed. Like, what would those ISOs and RTOs need to do in order to comply? Like, would they then have to speed up the rate at which they were making deals with Invenergy and other developers of transmission, or how would that sort of convert to more transmission?
So the grid operators would run a process, and really this is about transmission planning and how as a country we go about transmission planning. So the grid operators would have to look at their systems, and they would have to find where on their systems they need to be interconnecting to adjacent grids.
I see.
And that could be through a process where utilities are building that, and there's Invenergy or other independent developers, really ought to have a role in building some of that. One other option that we are really excited about and trying to educate folks on is what's called a subscription model for incremental capacity. So if we build the lines that we are currently building today, those lines will be operational and serving customers in the vast majority of hours during the year. But there may be times where during extreme grid events, grid operators need to call on these lines and say, hey, we've got an emergency need. And rather than having to go out and build an entirely new transmission line from one region to the next, if Invenergy or another developer already has a line that's connecting those two regions, and during those extreme cases, it is available for use, there should be some form of opportunity for the grid to say, hey, we're gonna use this during these extreme hours. And what we call incremental subscription capacity is a way that can help keep the cost of that transmission expansion down and take advantage of assets that are already on the system.
So, when I asked you that question earlier about waving a magic wand to fix a problem, it's interesting because I was expecting you to say that making it easier to permit transmission projects would be your answer. And now I'm curious why. Is permitting a secondary problem to getting the requirements correct in terms of how power needs to be able to move around the grid and then dealing with the permitting slowness?
We think transmission planning is the most important aspect of the permitting reform conversation. So the actual process that the country goes through to identify the need for more transmission and then have a mechanism to support that expansion, we definitely view that as the most important aspect of this. I talked earlier, average transmission line, takes 10 plus years to develop. So there are aspects where if there is a federal permitting process involved, we want to see that process fully staffed. We want the agencies involved to have the resources they need to make sure these processes are done in an efficient and timely manner. So that is critically important as well.
Hmm. Hmm. But it's interesting. Like, you need a plan for where the transmission
Yeah,
needs to go and
absolutely.
why, right?
Absolutely.
That needs to come first. So that makes a lot of sense. If you were to fix two other things, what would they be?
I think anything that the federal government can do to have a role to play in the supply chain process is critically important. So that could take a lot of different forms. I think this is something that the Department of Energy is taking seriously and knows that it is a challenge. So, just as that example I had given earlier, if you have a state backed operator on another continent that's in the market and having cascading effects across the supply chain, maybe there's a role that the US government can play as we are more proactive as a country in transmission planning. That gives us more visibility into what US developers need and US utilities need for these kinds of projects. So taking on that supply chain challenge is critically important.
Yeah. How familiar are you, Patrick, with the legislation that is proposed about permitting reform? And can you speak to what exactly is on the table there?
Well, there's about 20 proposals that I'm familiar with that all are in the mix. I think a lot of the conversation is focusing around the four bills that have been introduced in the Senate Energy and Natural Resources Committee and the Environment and Public Works Committee. There's both the Democratic versions and the Republican versions. So I think that kind of what's known as the four corners is shaping a lot of the debate, but there's over 20 different proposals that are out there and have different ideas that could be eventually part of that bipartisan agreement.
Can we focus on the four corners and just would you be able to outline the key components of these different bills?
I can really talk most about the transmission aspects of it.
That's fine.
So there's what we call the three Ps. So planning, payment, and permitting. And there are different types of solutions that address each of those three Ps. So, I've talked about the transmission planning aspect and the big wires concepts for interregional minimum transfer capability.
Hmm.
That's the planning piece.
Is that concept of a minimum power transfer requirement, is that consistent across all four of those bills, more or less?
It is, I think there's still a conversation to be had about kind of what ends up. And I think you've got different sides across the parties that are starting from different places. But I think that's an issue that has certainly gotten some bipartisan attention. Another issue is what's called cost allocation, which is just when you have, any transmission line that is planned and permitted, you have to figure out who's going to pay for that and how do you calculate the benefits of those lines, and then ideally have a situation where whoever is getting the benefit is also paying the cost for that. So the cost allocation issue is one of the main issues that's being addressed as this debate unfolds.
Hmm.
And you have other concepts that are out there. A transmission investment tax credit, we think that would be a very strong market driver in the same way that you have support for both wind and solar. Looking at something similar that would be a market driver for transmission. We do think that when you have a situation where it is a challenge to move projects forward, the more there is market pull to incentivize those projects, you've got to find mechanisms to do that when there's virtually universal agreement that these types of projects are needed.
Hmm.
But there are all of the inherent challenges of moving a project this size and scale and over a 10-year timeline forward. So the more support you have for that, the more likely that is to be successful.
Yeah. That's a very valuable sort of principle. I think that you outline there. When you have kind of large projects where there's huge public support and industry support and government support, and everybody's saying, we really need this. But when these projects also face just inherent challenges and complications, whether it's logistics or sort of supply chain, like these challenges that sort of exist outside of direct market dynamics, then it makes sense to create incentive to make these things happen, to make it easier for the market to metabolize the inherent challenges, to deliver the thing, deliver the value that everybody says we need and everybody wants. So that makes a lot of sense. And I thought that you framed that really nicely.
With the traditional electric grid systems, we had predominantly maybe fossil fuel energy and maybe hydro energy. And so we didn't need as much interregional transmission. Is that true? Or is this a newer thing we need because of the nature of renewables? Or is this something we would need to do anyways?
The grid has evolved over 150 years, and the whole trend line of that evolution has been towards greater regionalization and connecting systems, because the more systems you can connect, the more resources you can balance. So that's really been true even before advent of renewables. And it's why when Thomas Edison put the first power generation station online in New York City, probably connected a few city blocks at most. And from then on, the story was about different power plants being connected to each other, different local municipal utilities connecting to other adjacent municipal utilities. So this is a trend that has really defined the electric industry since its very beginning. And as we move towards a system where so much now of the imperative is tapping into the very best domestic renewable resources the country has, that also necessitates a continuation of that trend to make sure we can access that and then move the power around to where it's needed. So we have much more power than we can use, but we have to get to it and we got to be able to move it.
That's great. And as you think about the future of power generation and the speed at which the US will achieve a fully decarbonized grid, what is your sense of how quickly we'll be able to achieve zero carbon grid?
I do think it'll happen. It's happening faster than the expectation. So we're beating the forecast, which is good. And I think it will happen because it has to happen. And you've got companies like Invenergy and you've got teams like ours where we got 2,400 people who are united by a mission to make the clean energy future a reality, and it's happening today. I'm reluctant to be a prognosticator on it, but I think the targets that have been set for zero carbon by 2035 and by 2050 with the Paris Accords have galvanized the public and the industry and all the players that have to come together to solve this problem. I think there's a greater level of focus today than there ever had
Hmm. Hmm. Yeah.
How have you seen the IRA impact transmission in the last year to try to, for example, reach those 2035, 2050 targets?
The biggest thing that the Inflation Reduction Act has done for transmission is to provide greater certainty for wind and solar over the 10-year time horizon that it takes to build a transmission project. And so when I talked earlier about the uncertainty just being the most inherent challenge to developing transmission, the IRA is long-term certainty that helps establish that demand and just allows us as a transmission developer to understand what the world's going to look like down the road. So that really is the biggest piece of that. Now, the Inflation Reduction Act did not have specific incentives, or at least a specific investment tax credit like we talked about for transmission. So I think that's a piece that we still view as critical. And transmission expansion is essential for achieving the goals of the IRA. So I think that's an important piece too, is as much as 80% of the benefits of the Inflation Reduction Act won't be realized if we don't expand the rate that we are building transmission.
Terrific. Patrick, this has been a really fantastic conversation, and I just thank you so much for joining us.
James, thanks so much. It's great to be here.
And that's it for this episode of the podcast. Thank you again to Patrick Whitty, Senior Vice President of Public Affairs for Invenergy. To learn more about the science, policies, and other exciting developments in U.S. renewable energy, check out our other podcast conversations at climatenow.com. If you'd like to get in touch with us, email us at contact@climatenow.com. We hope you'll join us for our next conversation. Climate Now is made possible in part by our science partners like the Livermore Lab Foundation. The Livermore Lab Foundation supports climate research and carbon cleanup initiatives at the Lawrence Livermore National Lab, which is a Department of Energy applied science and research facility. More information on the Foundation's climate work can be found at livermorelabfoundation.org.